Okay, today we start the third of the 3 topics that we cover in calculus. We've done limits already. We just wrapped up derivatives. And so we're moving on to our third topic, which is integration. We'll be doing this for the rest of the year. Actually, not for the rest of the year. For a good chunk of time. And then we start to review. Review. AP test. Go away, have a nice life. Okay. This works better when you turn it on. We're going to do something called an antiderivative. Will, what do you think an antiderivative does? Animal. Right. Which means what?
I got you, coach.
Good. Okay, so for instance, if my function was squaring, what would be anti-squaring? Square root. If my function is multiplying, what would be anti-multiplying? Good. So they're inverse functions. Well, they're not really inverse functions. They're inverse operations. Okay, it's the opposite. And then I'll explain something called an indefinite integral. That comes later. So we're going to talk about general solutions. Then we're going to talk about what an indefinite integral is. By the way, new symbol today. It's going to be awesome.
Oh yeah.
We're talking about basic rules, how to do this stuff. And then we're going to look at a particular solution. And notice the top one is a general solution, the bottom one is a particular solution. We'll explain later. And I neglected to include something for you to do today. I apologize. Let's move on. Simple question. If I've got a function, f of x, and that function is 3x squared, there is some function, which we'll call capital F. So now we're introducing a new letter here, capital F. Okay. Hold on, before we do this, let's talk about that. So we've done f of x, and then if we take the derivative of f of x, we get f prime of x. And if we take the derivative of that, we get f double prime of x. Okay? That's old stuff, right? And then if we take the derivative of f double prime, we get f triple prime, et cetera, et cetera, et cetera. Now we're going backwards and introducing a new letter, which is capital F of x. So all 4 of these things are related. We've only done this so far going to the right. We'd like to be able to go to the left. And that's what we're going to talk about here. So, let's do this. What is the function that when I take the derivative of that function, I get 3x squared?
X cubed.
X cubed. Easy peasy?
Yes.
Any problems?
No.
No. Question?
Could you have a constant?
A what?
Plus 10. You would still get 10.
But it's x cubed.
No, but she said. Because a constant would drop out if you did
But
like capital
will there
F
ever
would
be
be like x cubed plus 10.
Yeah.
And then f of x cubed is the same as that.
Just close to
Why 10?
Or just any constant.
Pi.
Yeah.
E?
Yeah.
Negative 14. Of a billion?
I think so.
So it's not x cubed.
I mean, it could be x cubed. There's other possibilities.
Do you? Do you see where he's going?
Yes.
Do you see where he's going? I don't either.
Makes no sense.
We don't see where you're going. Could you explain that once more?
Oh, the x cubed plus 5.
I'm sorry, what?
It's like
Could it be like x cubed plus 5?
All right, so if I take the derivative of x, because the derivative of 5 is 0.
what you're saying, no?
If it was 10, x cubed plus 10, derivative.
Right?
I did that. Or did I?
Using the perfect segue.
Smooth on.
There are, however, a large number of solutions. It's not my first rodeo, kids. Okay, let's back up. That thing is called an antiderivative. It undoes the derivative. We're going backwards now. Instead of going from capital F to F, we want to go from lowercase f to F. In other words, what function is it that when you take the derivative, you get the answer that you're looking for? It's also called an integral. So we're going to use some words interchangeably. All right, so as we talked about, there are a large number of possibilities. I happen to choose 7 and negative 12. We talked about 5. We talked about 10. We talked about pi, e. Any constant that you put on the end of that would still give you that value of 3x squared because the derivative of constants are 0. The way we represent that, Logan, is C, which stands for cat. Very good.
That was close.
Whoops, going a little fast there. Because there's an infinite number of possibilities, this is called a family of antiderivatives. There's a lot of them, because any constant we put on the end of that would work. And there are an infinite number of constants. Later on, we're going to talk about the fact that we don't want an infinite number of constants. We want one and only one answer. To represent that, we use capital C, which is called constant of integration. That basically says, yeah, I know there's going to be some number at the end there. I don't know what that number is, but when I take the derivative of that number, it will disappear. It'll also be one of the most common things that you forget when taking antiderivatives. However, extremely important. Any problems? Let's do something incredibly simple. Here's y prime. What's y? No. Ooh, 2x plus c. I told you you'd forget about it. I thought it would take longer than 30 seconds. But it didn't. 2x plus c. Okay. General solution. Infinite number of possibilities, whatever you want c to be. Any problems there? Awesome. Some new notation. We get a new symbol. Woohoo! There it is. That's the integration symbol. It probably has a name. I don't know what it is. Some of you are going to struggle drawing one of those things. Some of you will just do that, which is not bad. Some of you will get a little bit more fancy.
I like that one.
Some of you will put a big honking dot and then make it all swirly and then put a big dot on the end. Some of you will just kind of go like that. You're going to have to practice a little bit. It does take some work. I would probably not go with the last one. And the big dots and the swirly is a little excessive, but somewhere in between. Gives you an opportunity to express your artistic abilities. Okay, so we've got that integral symbol. The stuff after the integral symbol is called the integrand. It's the thing you're taking the integral of. Then you'll notice that pesky little dx sitting there. You've seen dx before. Technically, it's called a differential, but in this case, it's called a variable of integration. It serves a very important purpose. Its purpose is to tell you what letter is the variable. We will see some integrands that have x's and y's and z's in there. They all can't be variables. This is multivariable calculus. Single variable calculus. Therefore, that dx or dy or dz or d alpha or d theta, whatever it is, tells you which of those letters is the variable. That's also something you'll forget about when writing integrals. You gotta have a dx on the end of it, or a dy or dz, whatever your variable is. That's the antiderivative. And then what's C called? Constant of integration. Put all that stuff together and you've got yourself a nice little problem there. It doesn't have to be lowercase f of x. It could be uppercase f of x. It could be s of t. It could be k K of Z. Okay.
Wow.
What's up, homie? Coming to chill on some calculus? Awesome. Do you want to sit here? So we won't go crawling in the corner back there. I should probably move because that would be awkward for both of us, wouldn't it? Bear in that. Man, this chair. Would you like a cookie?
Yeah, you want
I just like for stuff. Nah, no thank
Those two things are mutually exclusive. Want a Capri Sun?
Yeah, he wants a Capri Sun.
Absolutely.
No, that's
Just take it.
I'll just take it.
Yeah, he definitely wants one.
Yeah.
He's gonna make a sacrifice.
There goes his junk out.
Someone's got to take a spot. You got it.
You're gonna have to drink about 8 of those.
We only have 4, so we'll take it easy.
Brendan would find a way to make it 8. He stole it from somebody else.
He'd like take him out of his backpack at this point.
Where's my bag? Anyways, yeah, okay, so that's an indefinite integral. It's called an indefinite integral because we're getting a function for an answer, not a number. Later on, we're going to do it and get numbers for answers. But that's in the future, not now. How do we do it? We could continue to ask ourselves over and over again, what function do I take the derivative of to get this function? But eventually, at some point, we have to take some ownership and say, okay, I got to forget about derivatives. I just want to talk about antiderivatives. I want to be able to go backward. So we have to come up with a method or a way to explain to somebody how to take these antiderivatives. So let's start with this guy. I took f of x. I took the derivative of f of x, and then I took the integral of f of x, and I went back to f of x. Are you following that concept? They're like inverse functions, taking the square of the square root, taking the square root of the square. The antiderivative and the derivative undo each other. Are we good? Okay. What if I do it the other way?
Yeah.
Here I took the antiderivative, then took the derivative.
Okay.
We good with that?
Yeah.
So here's the big question. Why doesn't the second one have a C?
Oh.
Answer number 1, I screwed up. But then if I screwed up, why would I put a sentence saying, why did I screw up?
Diff.
Why is there no C on the second equation? Alex?
Because when you take the derivative of that function, so the integral, any constant just disappears.
Does that make sense to everybody? Anybody not clear on that? I'm interpreting the hump as a, he's not clear. Could you explain that?
So when you take the derivative of anything, even if it's an integral, the constant disappears no matter what it is.
So when I take the antiderivative of f of x, I get capital F of x plus c.
Yeah, for sure.
Then when I take the derivative of that, I get back to f of x, and the derivative of c goes to 0. Whereas in the top one, what am I doing second? In the top one, I'm taking the antiderivative. So when I take the antiderivative of a function, I've got to have a constant of integration. What I'm doing in the second one is ending with the derivative, therefore the constant disappears. It's a minor point, but it's kind of important to understand the difference between the two. What order did you do it in? Okay, so let's go back to this x cubed thing. What function, excuse me, what function, what's the antiderivative of x cubed? In other words, what function, when I take the derivative of it, gives me x cubed? Have it.
Capital F of x equals 1/4 x to the fourth. Yes.
Is he right?
Yes.
Plus c.
Are they right?
Yes.
How do you know?
Because if you take
Because, good.
If you take
Was there more coming after that?
You're not.
now there is.
Okay, go ahead.
If you take the derivative, it's going to end up being x cubed.
Beautiful. Any problems there?
No.
Well done, Evan.
You're
Oh,
welcome.
Evan. What's the antiderivative of x to the 7th?
Is it 1/8 x to the 8th plus c?
Hold on, let me ask my friends. Oh, friends, is it 1/8 x to the 8th?
Yeah.
Yes?
Yes?
Oh, Evan.
What does that say?
Is that an
U?
N?
That's an N, as in narwhal.
The rank is not
It's just
there.
1 over n
No.
x to the, no,
Incorrect.
1 over n plus 1 times x to the n plus 1 plus
1 over n plus 1 times x to the
n plus 1
n plus 1
plus c.
plus c. Is he right?
Yeah.
Yes.
You sure?
Yeah.
Well, x cubed would be, n is 3, so raise it by 1 would be 1 over 3 plus 1, which is 4, x to the 3 plus 1, which is,
Very nice.
he's a smart feller. Well done.
What the heck?
Evan, let's suppose I took you down to Algebra 70 down the hallway and asked you to explain that process to a freshman in Algebra 70. So you go up to a freshman in Algebra 70, they know what an exponent is. How would you say it in English where they would understand?
How do I say,
How would you explain that process to someone who doesn't know calculus?
well, if you have like x to any number,
Okay,
you're gonna want the exponent to be 1 bigger than that.
okay,
So you're gonna have x to that number plus 1,
okay.
and then you want that to equal, or you want the coefficient to equal 1, so you're gonna have that number times the 1 over that number. That's all I'm getting.
And
Yeah.
not bad. All right, so there's the rule, which is exactly what you said. Well done. And then in English, raise the exponent by 1, multiply by the reciprocal of that new exponent, which is pretty much what you said. This is really important. It's the basis of antiderivatives. No, not what I'm about to say. That is really, it's so important, in fact, I made it flash. Yep. If you missed it, that's how important it is. Flash 3 times.
Turn my mouth.
And that's about as many times as I can make it flash. You're gonna like the next slide.
We already know.
What? You know what it is? What is it?
That's garbage.
There is no product rule, no quotient rule, or no chain rule. You know how excellent that is? I made it flash.
I can't write it anymore.
Yeah.
There.
Stare at that for a little while, you'll have a seizure.
You can still see it.
Yeah, it burns into your retina. Yeah. It's a good one, right? Guess what many of you are going to do? You're going to try to apply the product rule, the quotient rule, or chain rule to integrals. And you know what you're going to get for that?
Nothing.
Come on, man! Because it flashes.
Are you making?
Don't screw up on the flashy things.
Still see it when I close my eyes.
That's also wrong.
So you're saying to yourself, this is going to be easy. There's no product rule, quotient rule, or chain rule. How rough can these integrals be? Right? They're actually not bad. Other than the basic rule we already covered, there's one other rule you need to worry about. Everything else is just algebra, which we're not ready to get into yet. We're just doing the basics still. By the way, there's no product rule, quotient, or chain. Here are some trig things for you. 6 of them. Why 6? Because those are the 6 that we have for trig functions. Now you might be saying, well, where did that, why secant squared? Who wants to know the antiderivative of secant squared? Nobody does. But if you look at the right-hand side of that list, those all look familiar. Sine, cosine, tangent, secant, cotangent, cosecant. In other words, what's the derivative of sine? Cosine. So therefore, what would the antiderivative of cosine be? Sine. What's the derivative of cosine? Negative sine. So what's the antiderivative of sine? Negative cosine. So we put the negative on the other side. And then the others are all variations of those that we've done. Now you might be wondering, well, wait a second, what's the antiderivative of secant? Just secant by itself. Yeah, we'll get to those later. We're not ready for that yet.
I don't want.
These are pretty flashcard worthy. You got to know these. And part of the problem that's going to show up now is, if you haven't already struggled when we were doing derivatives, remembering, okay, is the derivative of sine cosine or negative cosine? Is the derivative of cosine sine or negative sine? Remembering where to put that minus sign. Now that we're going backwards, it becomes more complicated. You just got to remember where that minus thing goes. For the first 2 at least. The rest we'll worry about those later. So I'm going to show you this method that somebody showed me a long time ago, and I thought it was the dumbest thing I've ever seen. But now I can't stop using it because it's so stupid. Okay? And it's called the stupid golf thing. So let's suppose you want to take the antiderivative of the sine of x. If you imagine the integral symbol as a golf club, and the dot on the sine as the golf ball, when you swing the golf ball, or golf club, it hits the golf ball, which travels to the other side, but it travels so fast you can't see it. Okay. Again, stupid.
What about the cotangent?
And probably 20 of you think that that's the dumbest thing ever, and you'll never think about that ever again. But for the other 6 or 7 of you that might help, you're welcome. Now you might.
What about the cosecant or cosecant times cotangent?
What about it?
We can't do that. For that.
No, you can't. You might be even saying to yourself, wait a second, why can't I take the antiderivative of the cosine and hit the O in the cosine with the golf club?
Too heavy.
It's too big. It's like hitting a playground ball with a golf club. You're going to hit yourself in the head with the golf club.
It
Doesn't work. It only works for sine. Tiny little golf ball. And again, if it doesn't make any sense, then don't use it. But if it helps you, great. Problems?
Yes.
Yeah. Sorry. Let me clarify. Any problems with the math? Okay. All right, let's do a quick antiderivative. Make sure you're on the same page. You have excellent All right, we good?
Yes.
Any problems?
Nah.
There you go. 2x to the fourth minus 7 cosine x plus c. Who forgot the plus c? Be honest. Nobody? One person? Sorry. What do you want? You forgot the c also? When the problems get more complicated, we used to process in derivatives, which at this point you probably don't even think about anymore. But when we first started derivatives, you spent quite a bit of time talking about, and that is how to attack a problem like that. And so we use a method where we rewrote it into something we can work with, then took the derivative, then simplified it. The same thing is true with antiderivatives. So for instance, before I was to take the antiderivative of that function, how would I rewrite that function?
You know.
Wouldn't change the 12x to the fourth. Minus
Minus x5.
5 times x to the 1/3 plus
To the negative fifth.
x to the negative fifth. Good. By the way, what's negative 5 plus 1? Negative 4, not negative 6. Some of you will make that mistake also. What's an equal?
Just wants to say it, or
Yeah.
so it's 12 over 5, x to the fifth. And then hold up, so that ends up being 1/3. That's 20 over 3, x, 4/3. Yeah? 20 over 3. Karen, what the hell? Hold up. 5.
All right, so let's do, we'll come back to the constant here. What's the exponent? Alex?
Yes?
What's the exponent?
In the antiderivative?
Right here. When I do this.
1/3.
No.
4/3.
4/3, right.
You have to multiply that with that.
No. Multiply by the reciprocal.
15 over 4. That's not fun.
No.
15 over 4 is 43 minus 3.
I know we talked about it up here, but is everybody good with where the 15/4 came from? Good. Remember, multiplying by a reciprocal of a fraction. Flip it over. 15/4. So multiply over, flip it over would be 3/4, and then times 5 would be 15/4. And then we can talk a little bit later about how to simplify that, like get rid of the negative exponent and do all that garbage. But for right now, I'm more concerned that you understand how to. Yes, sir.
There'd be a plus c in it.
Outstanding. Look what I just forgot. Plus C. Thank you. It's going to happen all the time.
12, which ends up being 5. Never mind.
Okay, we good?
Yeah.
Beautiful. That ends the day. We would normally stop there, but we're going to move on a little bit and start talking about particular solutions. I don't want an infinite number of solutions. I want a particular solution. In other words, when I take that antiderivative, I get a plus c. What can I do to get rid of the plus c? In order to do that, I have to know some initial conditions. You have to be given more information. Okay. So what we're doing is we're solving an antiderivative and getting a family of functions. So let's suppose I do an antiderivative and my answer is x squared plus c. So that's going to be a plain old standard x squared parabola. What's the plus c going to do to the function? Moves it up or down, correct. So I have an infinite number of possibilities that are slid up and down. When I find the particular solution, I want to know exactly where it is vertically. Is it passing through 0, 0? Is it passing through 0, 2? Is it passing through 0, negative 10,000? That process that we go through to find a particular solution is frequently called a differential equation. gonna step you through this here. So notice, I want to find the general solution of f prime of x, and then use that given information to find a particular solution. Don't get bogged down in the notation. If I take the antiderivative of capital F prime, what will I get? Capital F, correct. If I take the antiderivative of K triple prime, what will I get? K double prime, very good. Rewrite the function, take the antiderivative, you have a plus C. What do I do with the 1 and the 0? Plug it in. I plug in the 1 for x or y? X, and plug the 0 in for y, and so on. Okay, so there's our rewriting. Raise it by 1, and we get that. Plug 1 in for x, plug 0 in for y, and we get, sorry, I'm going too fast, that. C turns out to be 1. Which means our final answer is that guy. Only one possibility now, not an infinite number of possibilities. Question?
Where'd you get the 1 for the F capital F?
It's given information in the original function, or in the original problem. It says find the particular solution given f prime of x is equal to 1 over x squared with the starting conditions that f of 1 equals 0. Yeah, you need more information, otherwise you can't solve it. As I said, this is sometimes called finding a differential equation. There are entire math courses where you do nothing but this operation for an entire semester. I took it, it was fun. You do this one now. When you get an answer, check with your neighbors, make sure they have the same answer. Don't be bashful about using those calculators, kids.
When you get it to the I'm gonna laugh if like just I'm gonna laugh if just I when Emily gets to Yale, she takes classes and all of them are
Now, how do you use
Oh, it's like something.
I don't recognize it.
That's a one family exclusion.
The one in your, I'm sure you're still in the same shape where he like sits in the swim gym. I just talked about it. He's only got.
Oh, it's good.
Yeah.
I actually don't get it. So why should we stop
I think it's good.
You don't understand.
You got 2 one. How much you want the full one?
Got it?
You brought them in.
Lucy, what's C?
7?
Can somebody confirm?
Yes.
C is 7. Talk us through that, please.
Well, you do the whole thing and you get 3x to the third plus 2x squared minus 7x, or like, and then plus C.
Plus C,
And
got
then
it.
if you plug in 1, that equation equal to 5, solve for C, you get 7.
Outstanding.
What?
Ooh, boy, I didn't even do the work there. I don't have it, so we're gonna rely on you. I'm useless.
Unless you want us to do it on the board.
How about we do some trig?
No.
Oh, yeah.
Oh, hell no.
Oh, wait a second, kids. That's F double prime.
Wait a second.
What?
Wait a second. Nothing.
And by solving the differential equation, I'm asking you to find F, not F prime. So guess what?
You should do it twice.
Gotta do it twice. Well, you don't have to do anything.
But
But it asks for
Howard does equal, but.
So why is there, I'm giving you F double prime, I'm asking you to find F. Why does it give you information about F prime? No?
We have to find the concept of F prime.
Yeah. You're gonna get two constants of integration. When you take the antiderivative of F double prime, you'll get F prime with a constant of integration. Figure out what that constant of integration is, then you gotta do it again to get back to F with a new constant of integration. That's why you got 2 chunks of given information. That's cool. And there's some answer there. I don't know what it is.
There's not.
So that gets us to day 57. All right, you wanna do the problem?
Yeah.
Oh, all right.
Come on.
All right.
I'm doing right.
We can do this. All right. Yeah.
I hope.
-3 cosine x plus 5 plus c. And then plug in 0 for everything.
Let's see, that would be, whoops, that would be equal to 2.
Cosine would be 1, so that's
So that's 2 equals -3 cosine of 0
which is 1.
plus 5 sine of 0 plus c. Sine of 0 is 0. That goes away. That's 1. 2 equals -3 plus c. I'm going to get all fancies in my pansies and call that c sub 1.
Whoa.
Uh-huh, I can do that.
No way.
I just did. C sub 1 is equal to 5. Therefore, f prime of x, -3 cosine x plus 5 sine x plus 5.
Do it.
F of x would be equal to -3 sine of x minus 5 cosine of x plus 5x plus c sub 2. What do I plug in now?
Pi over 2.
Pi over 2. Let's see. That goes away. I'm running out of space here. I'll sneak it up here. Equals. Let's see. Negative pi is equal to sine of pi over 2 is 1, so -3 minus 5 pi over 2 plus c2. Wow, this is ugly. C2 is then equal to, add that to the other side, that would be 6 pi over, that's 5 pi over 2, added to the other side would be negative 2 pi over 2. So 5 pi over 2 minus would be 3 pi over 2 plus 3. I do that right?
Let me try.
5 pi over 2 minus 2 pi over 2 is 3 pi over 2. Move to 3 there. Oh yeah, I'm good.
Yeah.
So therefore, my final answer down in the bottom here, f of x is equal to negative 3 sine x minus 5 cosine x plus 5x plus 3 pi over 2 plus 3, as you can clearly see. Yes, sir.
It says negative 5 plus negative 3 minus 1. Does that stand for negative 3?
Here?
Yeah.
That's a 5.
Oh, minus 5.
But something like this.
Evan.
Why is it minus 5?
Yeah, it's minus 5 cosine.
If you plug in, plug in pi over 2. Yeah.
No, but you get that from 5x.
Oh, cranky! Uh-oh. Change the 3 to a 7? I made a mistake.
Negative 7.
Yeah, because you would have, because it'd be negative.
Negative 7.
Negative 7.
Do we have something like this in the quiz?
Anything's fair game. That's easy. Wait till you see what it gets to. So close this.
Can I see?